Because the coefficient in front of our x squared term isn't 1, we're going to need to use advanced quadratic factoring. And we can start out by figuring out what each of our portions of multiplication or addition have to equal. So the first two terms have to multiply to 9x squared. The last two terms are going to have to multiply to negative 80, and our inside and outside multiplication, when we add it together, is going to have to give us a positive 6x. We can then look at the factors of the coefficient in front of our x squared. Now, 9 has two pairs of prime factors, 9 and 1, and 3 and 3. Now, because our inside and outside terms have to add up to a relatively small number in positive 6x, we're going to start out by choosing the two factors that are closest to each other, so 3x and 3x. If we then look at the factor pairs of 80, we'll get 80 and 1, 40 and 2, 20 and 4, 16 and 5, and 10 and 8. And by the same logic as before, we're going to choose 10 and 8, the two numbers that are closest, and make the 10 positive so that we end up with a positive 6x when we add the inside and outside multiplication. As a final step, we want to double check to make sure that our factored polynomial is equivalent to the polynomial that we started out with. So we perform all of our multiplication, and we'll get 3x times 3x is 9x squared, which is what we're looking for. Positive 10 times negative 8 is negative 80, which is what we're looking for. And our inside term plus our outside term is going to give us negative 24x plus 30x, which will give us our positive 6x. And that is also what we're looking for. So our final answer is going to be 3x plus 10 multiplied by 3x minus 8.